Okay. In this illustration, it is given that there is a YDAC setup and there's a monochromatic source of light, point source of light. Uh, it is kept as shown in the figure, where the distance between the screen and the slit is 1 meter. The distance between the two slits is given as 1 centimeter, and this monochromatic source is at a distance of 50 centimeters from the slits. Now, if the source is given an instantaneous velocity of 1 millimeter per second towards the screen, if the source is moved towards the screen, then we have to find the velocity of the central maximum on the screen. So obviously, as the source moves towards the screen, the central maxima, let's say at any point of time, it is at a distance y. So it will start moving in such a manner that the path difference of the light which is reaching at this point from the two slits, this path difference should be equal to the path difference before the light reaches to the slits. So we can say this point, the point of central maxima, the path difference should be 0. So we'll start with the solution. Since C is the central maxima, delta x should be equal to 0. Now delta x should be 0. So before it reaches the slits, let's say before it reaches the slits, the path difference will be this distance is equal to x, this is d. So this distance will be equal to under root of d square plus x square. So before the light reaches the slits, it has already had a path difference of, this is the distance x, this is the distance of d under root of d square plus x square. So before it reaches there itself, it has got the path difference of under root of d square plus x square minus x. Now this path difference should be equal to the path difference that has been covered at this point C. So this path difference will be equal to dy by d. Now, if we try to find out what is y, that can be calculated as d by d into under root of d square plus x square minus x. Now, this can also be written as d by d into, if we take x common, so this will be 1 plus d square by x square whole to the power 2 1 by 2 minus x. Now this 1 and this x gets cancelled. This, since d by x is a very small quantity, we can use binomial expansion here. So we get y equal to d by small d in bracket d square by 2x. So this d and this d get cancelled. So we get y as d into small d by 2x. Now since y is the distance of the central maxima from O, if we want to find out the rate at which the central maxima moves, so we need to find out dy by dt. So we can find out dy by dt will be equal to d by d by 2 into minus 1 by x square into dx by dt. Now minus dx by dt is the rate at which x is changing. Minus dx by dt will be equal to v, which is given to us. So we can say that dy by dt is nothing but equal to d into small d by 2x square into v. So you can use the values. 1 into d is 1 centimeter, that is 10 to the power minus 2 by 2 into x square, x is given as 0.5 square into v is 10 to the power minus 3. So on calculation, this comes out to be 0.02 millimeter per second.